Hi Cougars! In this video I want to go over my teacher notes for Chapter 5, Nuclear Chemistry. So Section 5.1 starts out explaining what radiation is and the different types of radiation. There's alpha particle, beta particle, positron, and gamma rays. You're going to learn about all four of those. I have pointed out Table 5.2 from your textbook. The reason I want to draw your attention to that is because there are two different symbols for each type of radiation, and they are used interchangeably. One is not more correct than the other, so you should know both of them because they're used interchangeably. So I wanted to explain that, and then most of what is in Table 5.2 is in this table here. And then we also review Table 5.3 because it explains what can block each type of radiation, and there are some questions about that as well. So that's Section 5.1. All right, 5.2 goes more in depth on these radioactive decay nuclear equations or reactions. And what I really want to point out here is that it seems really complicated, but it isn't. You just have to remember to use the law of conservation of mass, which means matter cannot be created or destroyed, and this will help you balance any nuclear equation. They're not going to get too complicated in this class. So again, here's a table. You have the four types, and I'm going to talk about each one now. So we're going to start with alpha, and we know from earlier an alpha particle is just a helium nucleus. It has 2 protons and 2 neutrons. So here we have this atom is going to decay. You can ignore the 24,000 years for now. And let's say I didn't give you this uranium 23592 here. Let's say you didn't have that, and I said, what is formed? Well, using law of conservation of mass, we have to add up the top numbers to equal 239. So we're going to kind of pretend this arrow is an equal sign. So 4 plus 235 is 239. 2 plus 92 is 94. So this means that if I give you only two of these three items in this equation, you can figure out the missing piece. All right, so that's alpha decay. It's a helium nucleus. Next is beta decay. If there were one that students most often mess up, it's this one, because you have to add a negative number. So same thing, pretend the arrow is an equal sign. 0 here, 0 plus 131 is 131. Negative 1 plus 54 is 53. All right, and if you remember from last chapter down here, if you see an element written out, dash a number, that is the mass number. That's important to remember. Again, that's from chapter 4. And you'll keep seeing that over and over again. Okay, that's beta decay. It's like a really fast-moving electron. And then positron emission is kind of the opposite of that. But again, same situation. You have 0 plus 15 equals 15. And then plus 1 plus 7 equals 8. All right, and that's positron emission. So the difference between beta and positron, beta has a -1, positron has a +1. And then gamma radiation, there is no change in either number. And I'll be right back with a second video.